Okay, this is Max Doumitt. I'm doing my video of our problem set 2. So the first problem is to calculate what the balance will be after 1 year if you're making your minimum allowed payments to a credit card. So this will calculate your minimum payment based on these entries up here, and then monthly unpaid balance is going to be balance minus the minimum monthly payment. So you're basically just taking off whatever this was, the monthly payment, and then you're going to end up with the balance after that, and this is going to run 12 times for the 12 months in a year, and then it's going to print out your remaining balance after that. So it's going to basically just take off your minimum payment as the percentage, and then it's going to calculate what the minimum payment is and pay that onto the credit card. For problem set 2, we were trying to find out, not problem set 2, just problem 2, trying to find out the minimum that, or like, I guess is the minimum that we would have to pay every month so that we would pay off the balance in 1 year. We were using increments of 10 so that we could quickly use the method here to actually get to a number. So it wasn't as, how do you say, like concise or whatever as it could have been, as shown by the code in problem 3. But again, we're going to take the monthly unpaid balance. It's going to be equal to the balance minus the payment, so you're going to get whatever's left after you make your payment. You're going to make the new balance based on that, and then if it's less than 0, it's basically just is going to say, okay, are we done? Cool. If not, we're going to increment it by 10 and run it back until we get to 0 so that we know, okay, we're at the minimum. So this is basically just going to count up 10 to 20 to 30 to 40 to 50 until it gets to whatever the number was. I think it's 460. And then it's going to find out, okay, that's enough to pay off 5,000 in 1 year if you pay that every month. So it will stop there and then print that out. And the 2F is just here to make sure that it only goes to 2 decimal places, because otherwise it's going to print out a whole bunch of decimals, and that's not how money works, at least for our purposes. So on problem 3, I'm going to backspace this because it's hurting my eyes. It's the same kind of idea as this one, but we're not incrementing by 10 anymore. We're using a, hold on, I forget what it's called, using bisection search to do a similar thing here, but we're going to not have to do it in increments of 10. We can be a lot more precise, and it won't take forever. If we drop this down to 1 cent, it's going to take forever to run because it's just not built for that. It's not efficient code for that kind of work. So this is a more efficient way of doing that. We're basically going to work with a lower bound that is going to be just the balance divided by 12, because of course that would be the lowest. And then you're going to have, for this one, it's a little more complicated, but it is just the balance times 1 plus the monthly rates times the 12 divided by 12. So that will give you your upper bound. And then we're going to have our balance again at 5,000. The payment's going to be the lower bound plus the upper bound divided by 2. And now using this again to, it's the same kind of thing we had going on up here, or somewhere up here, but it is just going to get your monthly unpaid balance by subtracting the payment, and then of course add the interest on top. And then down here we have the fail safe, is not what it's called, but if it's 0, then we found the lowest payment and we're going to print it out. Or if the upper bound, lower bound divided by 2 is this, which is really low, that will also suffice for us. And if not, we're going to break down here, not break to here, but we're going to end up down here where we can either change the lower bound or the upper bound depending on which side of the token we're on. If the balance is above or equal to 0, we're going to change the lower bound to what payment is, and else we're going to go upper bound to payment. And then we're going to run it back until we end up with either a balance that's equal to 0 or an upper bound minus lower bound divided by 2 that is less than a cent, or I guess 0.001. And that is how these work. If we run it real quick, it's going to give the same thing that was already down there, but For the first one, it's going to give us a remaining balance after we made those minimum payments. It's going to be about 389 off what it was originally. And then the lowest payment, as you can see when we were incrementing by 10, is 460. And then when we get more precise, we're going to see that it's 451.63 actually. So this is what you would actually pay at the lowest. To drop it down, if you paid 460, then by the 12th month you would have a lower bill by what 9 times 12 is, I don't know, like 108. So it would have been like 340 bucks instead of the 460 that you'd been paying the whole time. So that is the code for problems 1, 2, and 3. And yeah, that is my video.